Good afternoon, dear colleagues and guests. Please allow me to consider open the meeting of the Dissertation Council for the defense of Andreeva Nadezhda Anatol'evna's thesis for the candidate degree of Physical and Mathematical Sciences on Specialization 01-0407 Condensed Matter Physics. The topic is investigation of ion molecular systems for greenhouse gas sorption by molecular modeling methods. And some general information. According to the order of St. Petersburg State University from the 10th of June 2019, number 6385/1, me, Shokin Alexander Kimovich, Doctor of Physical and Mathematical Sciences, Professor with the duties of Head of the Department of Statistical Physics of St. Petersburg State University, was appointed the Chairman of this Dissertational Council. And also allow me to introduce my fellow board members. Brodskaya Elena Nikolaevna, Doctor of Physical and Mathematical Sciences, Professor, leading scientific work of the Department of Colloid Chemistry of the Chemistry Institute of St. Petersburg State University. Rumtsev Evgeny Ivanovich, Doctor of Physical and Mathematical Sciences, Professor of the Department of Molecular Biophysics and Polymer Physics of Physical Faculty of St. Petersburg State University. Polotsky Alexey Alexandrovich, Doctor of Physical and Mathematical Sciences, Professor of the Institute of Macromolecular Compounds of the Russian Academy of Sciences. In the remote interactive mode, we have got Kuznetsova Tatiana Vladimirovna, PhD, Professor of Bergen University, Norway. First, I would like to emphasize that according to the federal law from the 23rd of June 1996, number 127, Federal Law on Science and the State Scientific and Technical Policy, St. Petersburg State University has the right to independently award academic degrees. The corresponding order on the procedure for awarding academic degrees at St. Petersburg State University, on the basis of which we conduct our meeting of the Council, was issued on the 1st of September 2016. In accordance with this order, the meeting of the Dissertation Council is considered eligible if at least 2/3 of the approved membership of the Dissertation Council takes part in its work, but not less than 4 persons. There are 5 members of the Council, so all of them are present, including those who are in the remote interactive mode. Thus, we have quorum. And the procedure of today's meeting is the following. The Chairman's summary report on the main content of the document submitted by the candidate and their compliance with the established requirements, answers to possible questions, a brief report of the candidate for the degree reflecting the main points of his research, up to 15 minutes, questions to the candidate strictly according to her report, responses of the candidate. No more than 2 minutes for one question. The speeches of all the members of the Thesis Council, by turns with reviews, with a statement of their positions, with questions and suggestions to the candidate, no more than 10 minutes for the speaker. The speech of the chairman with his review, the answers of the candidate for the degree to the questions and remarks of the members of the Dissertation Council, no more than 15 minutes. Open discussion, speeches at the request of those present at the defense of the thesis, with a brief presentation of their positions and or with specific questions and proposals to the candidate, strictly on the topic of the research, no more than 5 minutes for each applicant. And all interested persons are requested to register in the registration sheet Final answers of the applicants to the questions asked, no more than 5 minutes. The speech of the scientific supervisor, he is present today, no more than 3 minutes. And then a 5-minute break before an open vote in order to make a conclusion on the issue of awarding or not awarding the academic degree of St. Petersburg State University to the candidate. For the time of the discussion of the defense results by the members of the Thesis Council, the broadcast is turned off. And open individual voting, counting of votes by the chairman of the Dissertational Council with entering the results in the minutes of the meeting. Decision on awarding or not awarding the academic degree of St. Petersburg State University. And the final words of the applicant. Before switching to the realization of the meeting's rules of the procedure, I remind you to switch off your mobile phones. Thank you for your attention. The first point of our procedure, a brief information. Chairman's summary report: the thesis of Andreeva Nadezhda Anatol'evna for candidate degree of physical and mathematical sciences on specialization, condensed matter physics, on the topic investigation of ion molecular systems for greenhouse gas sorption by molecular modeling methods, was accepted for the defense by the order of Scientific Secretary of St. Petersburg State University from the 10th, and the Thesis Council was approved by the Scientific Secretary on the 10th of June 2019. And our candidate submitted the following documents to the Scientific Secretary: an application form addressed to the Rector of St. Petersburg State University about the acceptance for consideration and defense of the thesis, submitted on the 4th of September 2018. The review of scientific supervisor, Vorontsov Ilyamilov Pavel Nikolaevich, Doctor of Physical and Mathematical Sciences, Professor of the Department of Molecular Biophysics and Polymer Physics, and the list of publications containing 11 works, including 11 publications indexed in Web of Science and Scopus and in peer-reviewed. There are no publications from the list approved by the Ministry of Education and Science of the Russian Federation. The certificate about candidate examinations from the 17th of May 2017, issued by St. Petersburg State University, certifying that Nadezhda Anatol'evna successfully passed the candidate examinations on specializations 0104007, the history and philosophy of science, good, the English language good, the physics of condensed matter, excellent, the diploma about higher education, issued on the 1st of February 2008 by St. Petersburg State Educational Institutions, St. Petersburg Polytechnical University, certifying that Nadezhda Anatol'evna received qualification engineer on specialization, electroisolation, cable and condensated techniques. The thesis is done in Russian and English, both in paper-based version as a manuscript and in electronic form. The thesis is designed in accordance with the requirements of national state standard. It should be noted that all listed documents comply with paragraph 12 of section 3, procedure, presentation and defense of dissertations, procedure for awarding academic degrees at St. Petersburg State University. And now the brief report of the candidate. Thank you very much for giving the floor to me. My thesis is dedicated to the research of ion molecular systems for sorptions of greenhouse gases by methods of molecular modeling. As I have already mentioned, all results of the dissertations are published in peer-reviewed international journals, and up to the 1st of September 2019, they were cited 66. The results were cited 66 times. As you know, the main reason for greenhouse effect is greenhouse gases, and this phenomenon is widespread as global warming, and the main reason for this global warming is greenhouse effect caused by greenhouse gases. And today there is an activity aimed at reducing greenhouse gases in the atmosphere with the help of sorption of these greenhouse gases. In my paper, I studied new sorbate of dioxide of hydrogen on the basis of heterocycled ionic liquids, C60 fullerene, surface active ionic liquids, calcium and barium salts have been proposed and studied. The third and fourth chapters of my dissertation describe the study of carbon dioxide sorption through the mechanism of amination and urea reaction of cations for ionic liquids and fullerene. To study the reaction mechanisms, the thermodynamic potentials of the systems were calculated. Absolute thermodynamic potentials can be calculated by knowing the exact molecular distribution function. However, we can calculate the exact molecular distribution function only by precisely solving the Schrödinger wave equation. And the closest method to solving the wave equation is the coupled cluster method. And this is the only possible for single electron system. A mathematical apparatus for the calculation of thermodynamical potentials is represented in the next slide. Thermodynamical potential shows only the initial and final states of the system. To consider the process from beginning to end is possible only with the help of the methods of molecular dynamics. I used the molecular dynamics computational method. It is the complex of methods which was used in the PM7MD is represented in the slide. Currently, the most common method for sorptions of CO2 is the absorption by aquatic solutions of amines. For example, monoethanolamine. Monoethanolamine effectively absorbs CO2. It is chemically stable, is easy regenerated, although it has a number of disadvantages such as volatility, high corrosivity. In this regard, the development of used CO2 sorbents is actively ongoing. One of the directions for the development of new sorbents is ionic liquids. Ionic liquids are compounds which consist of ions but remain liquid in a wide temperature range. They have a number of positive qualities, such as non-toxicity, non-volatility, etc. Some ILs by themselves capture CO2, but to a lesser extent than aqueous solutions of amines. In my work, and ionic liquids and amines were combined to obtain a non-volatile compound capable of binding CO2 with the formation of carbamate, and each the amino group was sequentially attached to each symmetrically and not identical carbon atom. It is shown in this slide. For each step, thermodynamical potentials were calculated using the consequences from Gaus's law. All thermodynamic potentials are represented in the next slide. They are reduced to standard conditions. And analyzing the dependencies, we can conclude that which atoms, how heterocyclic cations of different structures differ from benzene molecule, and thermodynamic potentials were calculated for neutral benzol molecule. The correlation was obtained from cation cultures and free Gibbs energy. We found out that correlation between the Gibbs energy and the electron density distribution on the Cauchy ring. Thermodynamic potentials and the reaction of the formation of carbamate is represented in the next slide. Analyzing these dependencies, we can conclude to which position of CO2 molecule will be attached to the most energy profit, and comparing the results, we can conclude that aminated cations capture CO2 not worse than the ions of ethanol amine, but at the same time they have positive properties of liquid ions, and we managed to combine them according to the sorptions of hydrogen dioxide. In the next part of my work, I used fullerene as a non-volatile substance to which amino groups can be drafted to input to its sorption abilities with respect to carbon dioxide. Fullerene is not non-volatile material, thermally stable, and has many carbon atoms to which we can attach a large number of amino groups for sorptions of CO2. And due to surface tension, fullerenes are known for their participation in huge variety of chemical reactions. Thus, the prospect of functionalizing fullerene is almost endless. Thermodynamic potentials of the aminidification of fullerene and carboxamide formation as a functions of the number of attached groups. Thus, we conclude that the addition of up to 9 amino groups to fullerene and subsequent carboxamidation is an easy, realized, and promising reaction. Fullerene is a promising material for CO2 sorption, primarily due to its compact structure, which allows you to attach to it a large number of amino groups. In the next chapter of my work, I studied the sorption of carbon dioxide by salt of alkaline earth metals. It was found out that the calcium cations coordinates up to 8 carbon dioxide molecules in the first coordination sphere, forming unpronounced interactions of calcium with oxygen. Each additional CO2 molecule goes into the second coordination sphere. And the value of the standard heat of formation during the coordination of CO2 decreases somewhat when new molecules join the first coordination sphere. This slide shows the radial distribution function for all possible distances between cations and an oxygen atom in a CO2 molecule. The figures show the radial distribution functions between the cation and oxygen CO2 calcium TFPB and barium TFPB. Integrating the function of radial distribution, we can calculate the coordinational figure, the number of hydrogen molecules, and we found out that for calcium without anion, the coordinational number is 7.7, and for barium is less 3.9. When there is non-coordinating anion, this figure becomes lower. Calcium 5 and 5, and barium 3.6. This technology is advantageous because in this case for one calcium oxide there is one CO2 molecule, and in this case the sorption is up to 5 molecule CO2 for one calcium cation. Also, in the next part of my works, I studied surface active ionic liquids. They were investigated together with their experimentators. These are new ionic liquids which were obtained in the laboratory. Structure and their image, they are represented in this slide. The composition of anion, sulfate group, because polar sulfate group cooperates successfully with sulfate anion. The anions were combined with classical cations of ionic liquids. From the theoretical point of view, the free Gibbs energy was evaluated. The energy of the transfer of the synthesized IL from a non-polar solvent of an octanol to polar solvent of water was estimated. It was found out that one IL is more hydrophilic, the other more hydrophilic. The imidazolium cations is hydrophilic due to the presence of electron-deficient hydrogen in the imidazodium ring, which leads to the formation of a weak hydrogen bond with the water molecule. At the same time, the sulfate group actively interacts with the polar solvent, which is water. Thus, the hydrophilicity of the obtained IL was shown, and they were experimentally dissolved in water. The interaction of IL data with carbon dioxide and water was also studied, and the contribution of sulfate group was evaluated. Also, euphorium group also attracts CO2, but to a lesser extent. But the compounds which had several euphorium groups, the contribution of this group was more significant. And in this case, the sorption of CO2 was higher. And as for conclusions, the mathematical apparatus of the dynamics and quantum mechanics has been successfully applied to the search for new carbon dioxide sorbents, the study of amination and carboxamidation of cations of ionic liquids, and C60 fullerene to the study of carbon dioxide captured by surface active ionic liquids with anion and calcium and barium salts. When studying the amination of cations of ionic liquids, a correlation was established between the calculated thermodynamic potentials and the electron density distribution of the cations. The most thermodynamically favorable amination reaction occurs of the atom with the highest partial charge. The amination and carbamidation reactions do not contradict the concepts of electrophiles, CO2, and a set of nucleophiles of slightly different interaction forces, which depend on the position of the carbon atom in the heterocyclic cation to which the amino group is covalently bonded. The addition of each new amino and carboxamida group to C60 fullerene gives the same increment of thermodynamic potentials, Gibbs energy, entropy, and so on. Thus, the number of grafted groups insignificantly affects the Gibbs free energy. Using the developed methods of controlled annealing, a study was made of the ability of the calcium cation to absorb carbon dioxide and the search for global system minimum. Calcium and barium salts with weakly coordinating anions show several times greater sorption capacity with respect to CO2 relative to carbonization technology which is currently used. The efficiency of using molecular modeling methods in predicting the synthesis of new surface active ionic liquids and their selected physical-chemical properties has been demonstrated. Thank you for your attention. Any questions according to the report? Evgeny Ivanovich, please. Your work is calculated. Do you refer to any experiment? And do you have any forecast and experimental data concerning your results? Aminated ion liquids were obtained experimentally, and that's why this reaction is possible, and they are used in sorptions of CO2. Calcium and barium were not obtained. With tetra-twentyl baratum, there are compounds with lithium, and it is possible with calcium and barium. And free active surface ion liquids are also possible. And your planned things were started to be realized. We worked with experimentators, and they were proved. Our theoretical data was proved. Theoretical data, they supplement experimental data. For example, experimentator can define that ion liquid capture carbon dioxide, but they can't say which group participates in this process. But theoretically, we can model this process and explain that sulfato group works, euphorium group works, and in cation acid hydrogen atom works, but it is not possible to define experimentally. Any other questions? Nadezhda, tell me please, in your work, in which cases you used ready-made programs for calculations of quantum chemistry, methods molecular dynamics, and in which cases you had to invent something new? On the whole, I used ready-made programs, composite method G4, and the method of empirical molecular dynamics. But on the other hand, I had to program and calculate systems which I have to investigate. Initially, the data I inputted into program and created input data. And you had to write something for processing, of course, for radial distribution. And one more question. You studied in your work different classes of compounds which can be used for the sorption of greenhouse gases. Can you compare different classes? What is better for the solution of this ecological problem? Which solvents, on the basis of your results, would you recommend to develop and use, to apply? I think here we should, based on the tasks of this study, many factors should be taken into account: the cost, the process of the extent of regeneration. We can say that fullerene can be used in industrial scales. Today it is a very expensive material, but on the other hand, ion liquids is very prospective direction, because every year the cost of production of such ion liquids is lower. It is not a new thing, it's a usual thing, and many companies produce them, and I think that ion liquids is a very prospective direction. And the last question: it is very important not only to combine CO2, but also to the question of regeneration, of reverse reaction. Freeing of carbon dioxide, carbon. What can you predict on the basis of your calculations? The drawbacks of water solutions of amines, they are ion liquids are not so evaporating, but on the other hand, and with the sorptions the regeneration is quicker. When we use the salts of calcium and barium, the costs on regenerations will be less. I have a question. Tell me, please, when we speak about the sorptions of carbon dioxide, we mean the sorptions with gas phase, but here you consider different environments. In the form of particles or what? And how can carbon dioxide be delivered there? In practice, the sorptions of carbon dioxide in gas phase is not produced. In practice, the sorption is under higher pressure, because under usual pressure, this process is not profitable in energetic terms, and even if we use aquatic amino solutions, the process is possible under higher pressure. In my work, in the first and second parts, I used gas phases, but if we use it is in practice, we should use higher pressure. In the last final part, where there is an experiment, increased pressure was possible for the sorption. You showed the function of distribution, highlighted the importance of molecular function of distribution. It is gas environment, and if we speak about iron liquids, it can't be gas environment. I investigated the coordinations of the center of dioxide molecule. I wanted to find out the cation center CO2 molecule approaches. The coordination was investigated. And one more question. It is connected with thermodynamic function. They will be different in different phases and conditions. Do you take it into account? My calculations are under standard conditions. To compare them with table data. From the statistical physics, classical statistical physics point of view, under high temperatures, taking into account electronic densities can be just averaged. What is the role of the temperature? Did you examine it? Thank you very much. Are there any other questions? Tatiana Vladimirovna, your questions? We can't hear you. We can't hear you. Can you hear us? Now we can hear you. My question is about the precision, of the accuracy of calculations of coordination functions. 7.5. The accuracy was 0.1, 0.2. The accuracy is the distance. You made numeric. Did you make a numeric modeling, coordinational number? What was the accuracy of this integral? Up to 0.1 we calculated. I see. I saw in your slide 5.577. That's why I asked this question. Thank you very much. One more question. Concerning ion liquids, how did you measure them? With the help of laboratory experiments? And what are the other methods for these liquids? Theoretical theoretically, molecular dynamics allow us to evaluate the strictness. We tried not to intersect theoretical and experimental investigations. We tried to make them supplement each other. Are there any other questions? Now, let us turn to the reviews. Tatiana Vladimirovna, please switch on video. We can't see you. Maybe there is a demonstration of the screen, the mode of the demonstration of the screen. Please press 2 squares. There are no external reviews, and let's read out our reviews. Evgeny Ivanovich, please, the floor is yours. On the whole, I like the work because there is an actual and important practical task is solved, and I had a question about the theoretical results and its connection with practical parts. The main thing is experiment. It defines the results of the approach and whether the approach was proper or not. And I liked the work in terms of the tasks. The second thing, I'm not going to analyze the work in detail because the report of our candidate was too detailed. It seems to me that I'm not going to discuss the review and the experimental approach because we have already heard it. As for the results of the work, I had to want chapters 3 and 6. I would like to speak about them a little bit. Starting with chapter 4. Chapter 4 is dedicated to the investigation of the opportunity of the use of new sorbent of carbon and amino modified fullerenes and possible ways of development of this direction on the account of the use of high chemical activity C60. It is very important because here we can attach a lot of amino groups. Chapter number 5 considers the sorptions of oxygen. Semi-empirical methods of molecular dynamics is used in the work. Electrostatical and it is very important that the presence of euphorium groups in ion liquids increase the heterophilness, and this result is proved by experimental data. And chapter 6 contains the results of the investigation and carbon dioxides with the salts of calcium and barium. The aim of molecular modeling was to find anions which not impede the process and not block the sorption. The search of global mean energy minimum with the use of firing technology, and it is shown this very important quantitative result. And on the whole, this thesis is very novel and very important for the solution of main practical problem, the search for effective sorbents. Here, there is a new step in search for these new environments. As for the volume of the materials and the actuality of the tags, and the search for new ion molecular systems or sorptions, the thesis of Andreeva conforms with the main requirements stated by the order on the procedure of awarding degrees at St. Petersburg State University, and its author, Andreeva Nadezhda Anatol'evna, deserves the degree of the candidate of physical and mathematical sciences on specialization 010407.1 was not violated by our candidate. Alexey Alexandrovich, your review, your remarks. I'll try to be as brief as possible. I want to say that without doubt, the problem of the thesis is very actual. And in the light of recent news, when this problem was discussed in a United Nations organization, its practical significance is without doubt. Also, I would like to emphasize that in this work there is a separate chapter, it is introduction. The first, it is literature review. In the second chapter, the author describes those methods she used in her study, and then 4 chapters come with the original results. The work is, in fact, very big, and various types of sorbents were investigated. The methods of quantum chemistry and molecular dynamics were used. In this sense, as for the number of systems which were considered, the methods which were used, and the volume of work, the thesis is very significant and gives positive impressions, produces positive impression. But nevertheless, there are some remarks to the work. In chapter 5, when you study molecular dynamics method, you studied one ion couple and one molecule CO2. Is it enough to study such a small system to obtain reasonable and reliable results? My question intersects with the previous question. Is there any data which prove that a neighboring molecule does not influence the composition of the liquid? And how did you conduct verifications of the semi-empirical data? And the third remark, stylistic remark on page 45, the integration of the equation of the movement. The step of integrations should be less than the frequency of fluctuation. You meant here, I think, the period of fluctuation, but these remarks of recommendational character and did not reduce the high quality of the thesis. And the thesis conforms with the main requirements of the order from the 1st of September 2016, 6821.1 on the procedure of awarding degrees at St. Petersburg State University, and our candidate, Andreeva Nadezhda Anatol'evna, deserves the degree of the candidate of physical and mathematical sciences on specializations 010407, condensed matter physics, point 11 was not violated by the candidate. Can we give the floor to our candidate for the answers? Yes, we can. You know that the questions intersect. Please have the floor. Answering the first question, I am not going to read it out. We can receive it from the modeling. From modeling, indeed, the influence of the number of particles in the statistical mechanical ensemble on the calculated macro and microscopic parameters of this system has been studied in many works. It was shown that the local structure is slightly modified by the presence of non-coordinating particles. This is due to the structural features of the liquid phase in substances with low dynamic viscosity. On the contrary, the transport properties of the liquids proved to be extremely sensitive to the size of the ensemble. Since our work required a description of exclusively structural parameters, we found it relevant to use a limited set of independently moving chemical structures. This huge onion, it is not coordinating, and it does not influence the coordination of CO2 molecules. The second, how was the verification of the obtained semi-empirical calculated data carried out? In our work, salvation of the morpholinium cation in acetonitrile, we compared bond lengths and angles for three methods: PM7, M11, and MP2, HV post. Also, the author of the semi-empirical PM7 methods, Stewart, provided data which confirms the accuracy of the method based on determining the heat of formations, bond length, dipole moment, ionization potential for several thousand compounds compared with more complex methods. The data obtained indicates that the semi-empirical PM7 method is not inferior to the above-mentioned methods. Thank you for your remarks. Concerning the frequency, there was the period. Irina Nikolaevna, I will have to repeat what has already been mentioned. If we speak about the participation of humankind in the environmental protection, carbon dioxide is a huge problem to date, and the thesis describes the current technologies for the solution of the problems with carbon dioxide. So the main peculiarity of the study is high spectrum of the methods and systems which were investigated. But I want to say that the remarks and comments which are of recommendational character, the last 4 chapters with main results. In chapter 3, the main massive of calculational methods, we can say that although the author says that the aim of modeling of this system of different amino-modified ion liquids was the comparative evaluation of the efficiency as chemical sorbents of carbon dioxides, but it is difficult to find comparative analysis in the text of the thesis. Chapter 5, the other ion liquids is studies surface-active matter. There is a question about the size of these systems, but it has already been mentioned, because if we speak about water solutions, amino amphiphile ion, a lot of work is dedicated to. At the molecular level, you could use the most stricter modeling variant or consider more systems. And From my point of view, the inclusion of experimental parts was doubtful, and unlike usual ion liquids, in case of the attachment of molecules of CO2 to cation, is it the difference in mechanisms, the sequence of different levels of modeling? It would be better to compare different ion liquids using one way of modeling of both liquids. And in chapter 6, it would be better to model more accurately. And finishing the analysis of the thesis, all the results are contained in 6 published international licensed journals. They prove the necessity of further experimental research of new sorbents of CO2. And as for the volume of the data, the thesis of Andreeva, Nadezhda Anatol'evna on the topic investigation of ion molecular systems for greenhouse gas sorption by molecular modeling methods conforms with the main requirements of the order on the procedure of awarding of academic degrees at the St. Petersburg State University, and its author deserves the degree of the candidate of physical and mathematical sciences on specialty 010407, condensed matter physics. Point 11 was not violated. As for the question about the size of the system and comparison with the published data, because a huge number of works have been devoted to molecular dynamics modeling. And comparison with the literary data in our context is not relevant, because these systems are completely new and were obtained by our colleagues. Regarding the ability of using a larger system, this is irrelevant, since the coordination of CO2 and H2O molecules by polar groups does not depend on the size of the system. The small system research technique was worked out in my previous studies, electrostatic charge confinement using bulky tetraoctylammonium cation, and for anions, salvation of the morpholinium cation is in acetonitrile. Effect of an anion and sodium ion electrolytes based on ionic liquids, a role of cation anion hydrogen bonding, and show that the number of ion pairs does not affect the quality of the result. The second question, as for the experimental part, I was in Brazil when the experiments were conducted, and I took an active part in these experiments. They were conducted at the University of Porto Alegre. Question 3. In contrast to ordinary ionic liquids, in case of surface active ILS, the attachment of carbon dioxide molecule occurs to the anion. The question arises regarding the attachment point of a carbon dioxide molecule. It does not depend on the charge of the ion, but on the presence of active centers in it. The polar surface group is a strong attractant for a CO2 molecule with a quadruple moment. Cation is also a sorption center, therefore there can be 2 sorption centers in an ionic liquid. It would be interesting to model more system in order to see the distribution of CO2 around anion and cation. There is a different mechanism, and it would be interesting to model. In the graph which is presented in this slide, there are peaks which correspond to the interaction with cation, and in some cases the interaction with anion. Of course, the modeling should be more accurate with the use of quantum mechanical considerations. Strict quantum mechanical modeling of such system has already been made many times. Our goal was to adapt a new method for analyzing a large number of systems per unit of time. The results obtained by the PM7MD method were compared with the results obtained previously by more accurate methods. We adapted new methods, as I have already mentioned. It's a quicker methods, and it can find the global minimum in this system. It is a question of verification. Thank you very much. Thank you. Tatiana Vladimirovna, please, your review. Tatiana Vladimirovna, can you hear me? The thesis is dedicated to the development of the sorbents of carbon dioxide and they investigated according to 4 directions, as well as industrially investigated developments. There are 11 publications in international peer-reviewed journals. It's a very positive moment, and empirical data was obtained and semi-empirical method of molecular dynamics was applied to investigate the interactions, and it allows to model the process from the beginning to its end. A lot of very interesting data was obtained concerning the activity of the absorption and its dependence on the placement, and correlation was obtained. The main results of the work were represented at workshops and international conferences in Brazil, for example. The results were used for the synthesis and prediction of the properties of surface active liquid ion on the basis of anion sulfate. It allows us to conclude that the thesis conforms with the requirements for the thesis, and our candidate deserves the degree of the candidate of physical and mathematical sciences on specialty 01, 04, 07. Thank you very much. There were no remarks. I don't have any remarks. And my review, the review of the chairman. In fact, I would like to say that I agree with the opinion of my colleagues. For me, I was impressed the broadness, the broad nature of the interests and tasks which were successfully solved, and the difference of the methods which were used, which are not characteristic of the narrow specialized thesis. The content of 2 paragraphs was very narrow, but starting with the 3rd paragraph. But in this respect, I highly appreciate this thesis, and I want to say that our task is to stress qualification component of this thesis. Our candidate demonstrates herself as a specialist. As for the results of the thesis, I would like to highlight modified cations of ion liquids which combine the carbon dioxide energetically protofable, but rather than ethanol lamine, and modified fullerene demonstrates comparable sorption properties in relation to CO2, but unlike water solutions of secondary and primary amines, these results and other results which are fixated in the thesis, they are new, interesting results which can be applied in practice. And from the formal point of view, the thesis conforms with the main requirements stated by the Order on Awarding Scientific Degrees at St. Petersburg State University. And I have no special remarks. Now we give the floor to the scientific supervisor, Pavel Nikolaevich. Please have the floor. Nadezhda Andreevna finished graduated from Polytechnical University in 2008, and since 2015 she started working at Federal University of São Paulo, Brazil, under the supervision of Professor Charlova, and her scientific topic is connected with the main practical problem of our time, the problem of global warming, caused by the greenhouse effect, and in particular CO2. The thesis is dedicated to the study of the range of molecular systems which are more effective for CO2 absorption. These are ion liquids, fullerene, and its derivatives, calcium, barium, and so on. The approaches which were realized in the work, these are molecular dynamics with the use of the methods of the functional of density and molecular modeling, with the use of the methods of the functional of the density. The methods were described in chapter 2.3. There is a full review in the work before chapter 1, and there are more than 250 references, and their preparation of the thesis was done in Russia when our candidate returned to St. Petersburg, and she worked at the faculty of physics, and our candidate made a contribution, and the results were published at peer-reviewed international journals, and she wrote 11 articles. In the course of work under the thesis, Andreeva showed independence, accuracy, and her interest in the topic, which is necessary for a researcher. And the English version of the thesis is very successful and very well written. I am sure that Nadezhda Anatol'evna Andreeva deserves the degree of the candidate of Physical and Mathematical Sciences on specialization condensed matter physics. Pavel Nikolaevich, thank you very much. And we have time for possible questions or speeches of all those who are present today. Are there? Can I say a few words? Evaluating the work on the whole, I would like to emphasize two moments. The first one, it is of high academic interest because here the ways of obtaining the objects which are effectively in solution of important problem are offered. And as for practical significance of the results, it is possible to, well, if you solve practical problem, there are two moments, resultativeness and efficiency of the methods. It would be better to evaluate it, to work in practice in the near future. You should take into account the combination of the cost and efficiency. And only in this case it will define the results of work and the opportunity of the use of these results. And from point of view, the study is very important from the practical point of view. In the text, there are no such recommendations. Thank you. Thank you very much for your remarks. It is a recommendation for the future. Are there any volunteers? Any other volunteers? And now I announce the break. And I think it's not necessary to give the floor to our candidate for the answering to the questions. I announce a 5-minute break in order to discuss by the members of Dissertation Council the issues of avoiding a scientific I remind you that the decision of the Dissertation Council on the issue of the awarding the degree is considered positive if more than half of it voted for, but not less than 3 members of Dissertational Council who participated in the meeting. Brodskaya, I'm for. Evgeny Ivanovich Rumtsev, I'm for the awarding of the academic degree to our candidate. Alexey Alexandrovich Polotsky, I'm for. Tatiana Vladimirovna, I'm for. Thank you. As a chairman, I'm for the awarding of academic degree of the candidate of physical and mathematical sciences. Counting of votes and announcement of the results of voting: 5 against 0. There are no those who voted against and who abstained. Decision on awarding the academic degree of the candidate of physical and mathematical sciences on speciality 010407 condensed matter physics to Nadezhda Anatol'evna Andreeva is accepted. Now the final words of the candidate. Thank you very much for the high appreciation on my work. That's all. And on behalf of the board, I would like to wish you successful work. All our remarks will help you to improve your investigations in the near future. For example, in order to check with the help of molecular dynamics and the results within the frames of quantum mechanical calculations, it would be better to check them and also consider them under different temperatures to check the changes. I wish you every success in the further work, and please study your topic. The meeting is declared closed. Thank you all for participation. Please switch off the live broadcast.